Look around our planet today, and you'll find environments perfectly tuned for life. We have rainforests brimming with fresh water, breathable air, and stable temperatures. We are so comfortable in this specific climate that we've built entire civilizations on the assumption that this stability is permanent. But pull back from our atmosphere, and that illusion fades. In the freezing, irradiated vacuum of our solar system, an oasis like ours is an extreme statistical anomaly, and the pristine conditions we rely on right now didn't form through a gentle, peaceful process. They are the direct result of unimaginable cosmic violence. We survived a 14 billion-year chain reaction of planetary collisions, freezes, and asteroid strikes. To understand our origins, we must rewind to absolute silence. About 14 billion years ago, all matter and energy in the universe was compressed into a single point smaller than an atom. Then it rapidly expanded outward, filling the void with superheated gas. This diagram illustrates the next critical step. As the universe expanded, a new force took hold: gravity. It grabbed scattered hydrogen and energy, pulling them together to forge the very first atoms. As billions of these atoms clustered together, the sheer crushing pressure of gravity eventually ignited them, sparking the nuclear fusion that created the first stars, and eventually our own sun. The infant Earth remained a hostile sphere of boiling rock, battered by relentless meteor strikes and smothered by rivers of magma, with zero oxygen in the atmosphere. That intense heat was a required mechanism. It acted as a cosmic furnace, smelting the raw atmospheric dust and gas into the solid crust we stand on today. Once the crust formed, Earth faced its first planetary crisis. A Mars-sized planet named Theia hurtled through the solar system and slammed directly into Earth, shattering the outer layers of both worlds. The vaporized rock and debris from that collision didn't drift away. Trapped by Earth's gravity, it clumped together to form our moon, which acted as an anchor, eventually stabilizing our planet's wild rotation and giving us regular seasons. Next came a relentless, millions of years-long bombardment. Millions of meteors, effectively dirty snowballs packed with ice, crashed into the lava-covered surface, instantly vaporizing into storm clouds that cooled the crust and filled the first vast oceans. This graphic shows what happened inside those early storms. Constant lightning strikes interacted with deep-sea volcanic gases, sparking chemical reactions that combined raw elements into amino acids, the essential biological building blocks of life. The events that would instantly destroy modern civilization, a planetary collision, and a relentless meteor bombardment, were the exact delivery mechanisms that made biology possible. Even with water, survival was difficult. During a phase scientists call Snowball Earth, global temperatures plummeted to -18 degrees Celsius, encasing the planet in a thick shell of ice and forcing early single-celled life to adapt near hydrothermal vents deep underwater. Intense pressure beneath the ice triggered massive volcanic eruptions. These volcanoes punched through the frozen surface, pumping heavy layers of carbon dioxide into the atmosphere, which trapped solar heat and melted the glaciers. As the ice retreated, early ocean plants consumed that volcanic carbon dioxide to fuel photosynthesis. In return, they expelled a waste product that would alter the planet's chemistry: breathable oxygen. With oxygen saturating the air, complex life crawled out of the oceans and rapidly diversified across solid land. This explosion of biological adaptation led directly to the global dominance of the dinosaurs. Then, 65 million years ago, a 27-kilometer-wide rock traveling at 22,000 miles per hour slammed into the Gulf of Mexico. The impact instantly triggered towering tsunamis, massive earthquakes, and a 200 degrees Celsius global firestorm. The fallout wiped out 75% of all plant and animal species, breaking the food chain and starving the massive reptiles. But by clearing the top of the food chain, the asteroid acted as a necessary biological reset button. In the dark, ash-choked wasteland that followed the asteroid strike, the massive caloric requirements of the dinosaurs became a fatal flaw. Only tiny, scavenging mammals, weighing less than 25 kilograms, could survive on the sparse roots and insects left behind. As the ash settled and forests regrew, those surviving mammals thrived. Over millions of years, they adapted to the new environments, evolving into early primate ancestors navigating the dense, lush jungle canopies of Africa. But the geology of the Earth shifted again. Tectonic plates collided, pushing up new mountain ranges that physically blocked the rain-heavy African monsoons, slowly replacing the thick jungle canopies with vast, dry savannas. This forced transition to the ground triggered a cascade of anatomical shifts. Tails disappeared, limbs lengthened, and our ancestors began to walk upright to spot predators across the vast savanna. Every major human milestone, from bipedalism to the development of complex tools, emerged only when a shifting climate destroyed our previous way of life, leaving radical adaptation as the only alternative to extinction. Looking closely at our genetics provides proof of this shared, chaotic history. As this graphic illustrates, humans share roughly 50% of our DNA with bananas. That overlap exists because every living thing on Earth descends from those exact same surviving ancient cells. We are the improbable survivors of a brutal 14 billion-year gauntlet of cosmic fire, ice, and rock. But today, the dynamic has flipped. Humanity has replaced cosmic disasters as the primary disruptive force shaping the planet. Through massive industrial pollution and rapid terraforming, we are aggressively pumping carbon back into the air, systematically undoing the delicate atmospheric balance that took millions of years and countless cataclysms to stabilize. Earth has endured magma oceans, total planetary glaciation, and massive asteroid impacts. It will always survive and recover from whatever we do to it. But if we fail to protect the specific, fragile biosphere that sustains us, we will just be the next extinct species.